Log change log sine and theta, right? This was the change in velocity if the object is moving in a circle, right? And we also saw that what is the relationship between linear velocity, angular velocity, and what is the center velocity. Things and between some questions. Let us quickly finish this and then move on to the I will pick
Okay,
the
sir.
question. I will pick question and then so this one. What is correct? Yes, hello, okay, question.
Yes, sorry, sir.
Okay, so now let us quickly. So what is the linear velocity if omega is this, r is this, right? So how do we calculate the linear velocity?
Sir, V is equal to omega into radius R.
Yeah, omega cross. So in vector form, this is right. Good.
Yes, sir.
Yeah. And if you want to find out the magnitude, so this is omega r per bit, right? So this is
Yes, sir.
what we have. Okay. So now omega is given. This is 3I minus 4j plus k, and r is also given, which is 5 by 6j plus 6. So we can calculate this linear velocity, and that would be simply the cross product of this, right? So, and we have to remember that same I cross I would be how much?
1.
I cross
Sorry,
what?
0.
Cross, right? So 3I 0 3I, and so we have a 3 minus 6 and I cross G. So I cross J is K, right?
Yes, sir.
And then we have plus 3 and 6 and then I cross K. So I cross K is how much?
J
We're going in the opposite.
minus
So
J,
plus
sir.
G minus J.
Minus.
And, and then we have this plus minus of 4 and 5 and J cross. So J cross I is minus K hat, and then we have this minus 4 and this is 0 and this is 6 and J cross K is, and then the last one is K, so 5 and K cross I. K cross I is G, and
Yes, sir.
then K, so then minus of K cross G, that is minus, right? So now we have all these things, and then we can write this is minus 18 K hat plus 18 J hat minus 20 plus K hat, and then minus 24 I hat plus 5 J hat minus minus plus 6 I. So we have minus 24 plus 6. So minus 89. And then we have J and J. So minus 30J and 20K, so plus that. Right?
Yes, sir.
Quickly note it down and then whenever you have put it down,
Yes, sir. Finish.
you have to always remember that magnitude of the velocity that is same, right?
Yes,
But
sir.
only the direction is changing in circular motion, right? So
Yes, sir.
only the direction is changing, but the magnitude of velocity is changing.
Yes, sir.
And now let us do this 90. So the magnitude of displacement of a particle in a circle of radius a with constant angular speed omega varies with time t is, right? So this is angular speed and this is time. So what would be the angular distance? What would be the
Sir,
angular
can
distance?
it be 2v sin theta by 2?
We are not calculating the change in velocity. I'm asking that we have this angular velocity omega, this is constant, and we have some time. So what
Yes, sir.
would be the angular distance?
Angular distance.
Angular
Um,
velocity,
yeah,
how do
W
we
is
define
equal. Sorry, sir.
W is theta by
Theta
t,
by
right?
t. Yes, sir.
That is how we define the angular velocity, which is angular distance by time. So theta would be omega t, right?
Yes, sir.
So let's make a circle, right? And we draw to so we have this circle and the object or the particle, let's say, was here. So it was here, and then it has covered this distance.
Yes,
So
sir.
this angular distance, this is omega t, right?
Omega. Yes, sir.
Because this is the theta, right? So this is the distance. So particle was here at A. Now the particle is at B. So what would be the what would and its radius is A. This is A. This is A. So what would be the displacement from in going from A to B? What would be the displacement?
Sir, length by radius. Theta is equal to
So
length by
that
radius.
theta equals to length by radius is another thing. That is parallax
Length by
distance
time. Sorry.
by time. This is this theta is already the angular distance, right?
Yes, sir. WT. Omega t.
Okay, so I'm asking that what would be the displacement from A to A? That would be this length.
Yes, sir.
right?
Yes, sir.
Is that so? We have to find out this, that is the goal in here. So we have to find this AB distance. And to calculate AB, what we get. So this is the chord length that we have to find, right?
Yes, sir.
So let us find out. Uh, so we can think of this, but let us find out the model. So this is omega t. If I draw a perpendicular, think about another way. So let's say I have drawn this perpendicular, right? And this total length is A. This total length is A. And this is A, this is theta. So what would be this length?
It will be height.
Yeah, so it will be height, but what would be this height? From using the trigonometry. Remember the
Trigon.
resolution of vector.
Um,
So if this
down one
is
will be
theta,
cos
this,
theta
so that would be r cos theta, and this would be
r sin theta.
right. So similarly, we have this A, this is omega t, so that would be A sine of omega t. Am I correct?
Yes, sir.
And from here to here, that would be A cos omega t. Correct.
Yes, sir.
So I have this length, right? I have this length and I have this total length. So I can calculate this way, right? That would be how much?
A minus a cos omega t.
Ab- Absolutely right. So A minus A cos omega t. Good. So I have this length and I have this length. So I can calculate this AB, right?
Yes, sir.
So AB would be how much? This is the hypotenuse, right? This is 90
Yes.
degree. This is hypotenuse. That would be perpendicular square plus base square. Correct?
Yes, sir.
So, so
So
perpendicular is
a
this
sin omega t square.
plus base is
A minus a cos omega t, the whole square.
and this is the answer that we have find out. So let us find out that this is a square sine square omega t plus this is a square plus a square cos square omega t minus 2 a into a cos omega t. So this would be a square sin square omega t and a square cos square omega t. A square is common, so that is sin square omega t plus cos square omega t. How much is this value?
One, sir.
Good. So this is 1. So this is a square into 1a square plus a square, that is 2a square minus of 2a square cos omega t. So we can take a square common and outside, and then 2 is also common, and this is 1 minus cos omega t. So how can we write this 1 minus cos omega t in terms of some
Sin omega
square?
t.
Minus cos omega t, right?
Yes, sir. I've learned in trigonometry.
So sine square theta plus cos square theta is 1. So if you are saying sine square theta, so that should be 1 minus cos square theta, right? Do we have a parity?
Sorry, sir.
So 1 minus cos omega t cannot be sine omega t, right? Because this
No.
is the relation.
Okay, sir. It should be square.
Right? Yeah, it should be square, but we have other relations. I guess that thing we have done at some point of time, but let me just revise that. So we have cos 2 theta. This is equal to cos square theta minus sine square theta, right? Or this
Yes, sir.
is 2 cos square theta minus 1, or this is 1 minus 2 sine square theta. So we can write, let's say I use this relation. So we can write 1 minus cos 2 theta equal to 2 sine square theta. Okay,
Yes, sir.
so we can write, so you can see from here, right? So how can we write 1 minus cos of omega t? How can we write this? That would be 2 sine of square and omega t by 2. Clear?
Yes, sir.
Because when the angle was 2 theta, so that was half of that. So when angle is omega t, so the angle would be half. So this is A and 2 and 2 and sine square omega t by 2. So this would be A sine omega t by 2. So that is the displacement. Is this clear? Okay.
Yes, sir.
So 2A sine omega t by 2. So please note it down, and if you have any doubt, please don't hesitate to ask. Okay.
Okay, sir.
And I am thinking that how can we calculate this chord from some another analogy? How can we do that? That, that is- Yeah, whenever you want me to scroll down, please.
Okay, sir. Finish, sir.
Okay, so then please.
Finished, sir.
Okay, so this just recent question from ITJ, right? And this
Sir,
can, yes,
I heard and they changed the syllabus for JEE.
yes, you have there's a what?
I've heard they have changed the syllabus for JEE little bit. They removed something.
Yeah, yeah. So yeah, that we can, right? I will look at
Oh,
whatever the topics that there.
okay, sir.
Yeah, and then let us do this 60th question. That can tell me easily, right? So please tell me what would be the answer of the 60th question. That we have done. This question we have done already, but so we have
Okay, sir.
uh, yeah, we have a particle which is moving in a circle with, let's say, 10 meter per second. So this is moving with 10 meter per second, and then it has covered a 60-degree angle. So has reached here, and my velocity is 10 meter per second. So we have to calculate what is the magnitude of this. So your favorite formula, what is that?
Nothing, sir. My favorite
Mhm.
formula.
So change
2v
in
sine theta
magnitude,
by 2.
change in, yeah. So 2p sine theta by 2, right? So how much would that be? This is 2, 10, and sine of 30. Right. So how much would be this? 2, 10, and
1 by
1
root 2.
by 2. So 10%. Right. Yeah. So for this case, you see that the velocity change is 10 meter per second. Magnitude of velocity. Okay. So yeah, and then we can do this. Yeah, please quickly note it down, and then we can do this next question quickly, and then we will move on to the next chapter.
Finished, sir.
Please solve this. Yeah, then it is one particles with the relative velocity. So we have to find out VA minus and this we have to find out at t equal to pi by 2 omega, right? So this we have to find out. And yeah, so both have equal angular speed, right? So angular speed is omega. Angular speed is omega, and we have to find out that the object is at this place, and the other object is moving in this place. This is moving in this smaller circle R1, and this is moving in bigger circle R2, right? And we have to find out what is VA and what is VB at t equal to pi by 2. So time is given, right? Angular speed is given. What you can calculate? Yes,
Speed and time is given.
yeah. So angular speed is given, time is given. So then what you can calculate? Angular
Distance?
speed, time, angular distance, right?
Yes,
Angular
sir.
distance we can calculate. So angular distance for the case of this A particle, that would be how much? So it starts from here. So that would be omega into speed into time, right? So this is pi by 2 omega. So this is pi by 2. And because they are moving with equal speed, so theta b would also be pi by 2. So A has moved pi by 2 angle from here. So how much is pi by 2 angle from here? This is this one, right? So A has
Mhm.
reached here, right?
Yes, sir.
And tangent to this circle is this direction. So this is VA, right?
Yes, sir.
And then this B is again, it has also covered this 90-degree angle. So B is where? B is here,
At R2.
right? So
Yes,
then
sir.
it is moving in this direction, right?
Yes, sir.
This is V. So now we have to find out the magnitude of VA. Magnitude of VA would be omega r perpendicular. Is that correct?
Yes, sir.
This.
Yes, sir.
So omega RA is how much? R1, right?
R1.
Similarly, yeah, because this is the R1, right? Perpendicular
Yes,
distance
sir.
from here. So this is the axis of rotation and this is the perpendicular distance from here. So VB would be how much? Omega RB. So this is
Omega
omega
R2.
R2, correct?
Yes, sir. Yes, sir.
Now, now we have calculated the magnitude. So VA vector would be VA magnitude and direction of VA is in which direction? What is the direction of VA?
Anti-clockwise. Negative.
Yeah, so we are talking about the direction of linear velocity. So this is in what direction? Negative, yeah,
Negative?
you are saying negative, but what? Negative of what?
Negative of what?
So we're not talking about the
Negative pi by
angular
2.
speed. Direction. Just see this. This is y, this is x. So in which
Negative
direction
I cap.
VA is? Negative I, right? So that is negative I. Good. And VB is, what is the direction of VB?
Negative I cap.
Negative I cap again, right? So that is negative I cap. So then we have to find out the VA minus so VA minus of VB, that would be minus of omega R1 I hat and minus of omega R2 and minus I. So this is minus omega R1 I hat plus omega R2 I. So we can take omega common, right? And that would be R2 minus R1 and I hat. What is the option? Is this clear?
Yes, sir.
Yes, please note it down. Please note this part
Okay,
down
sir.
and then we'll start the chapter. Whenever you have noted it down, please.
Okay, sir.
Yes, whenever you have noted it down, please.
Okay, sir.
Yeah, your voice is breaking.
Finished, sir.
Oh, finished. So now this chapter is also completed, and now let us do this chapter. So the next chapter is about the laws of motion and all the forces, the general forces that we have, right? So we already know that what is the law of inertia and what is the third law of motion, which is action and reaction. So the second law of motion is right. So the second law of motion that tells us about the external force, right? So if external force is applied, then there would be change in momentum, and that change in momentum, so change in momentum, right? This tells us about that external force. This is equal to y dt, right?
Yes, sir.
And where this p is mass into velocity, right? And if we put, so this d is representing the change in momentum, right? So we can
Yes, sir.
write, we can write this as p2 minus p1 divided by, let's say, delta t. Okay. And we can write this p2 minus p1 as m, let's say, then we can write this also as delta p by delta t. So this one is the instantaneous force, right? So this is instantaneous force, and this one is the average force, right? And
Yes,
we
sir.
also know, yeah, and we also know that there is a quantity which measures the change in inertia, right? And that is called the impulse. So impulse is represented as change in momentum, right? So change in momentum. So we can write this delta p as I, and this I would be how much? So if we put this I value in here, so F external, this would be I by delta t, and we can calculate this I as F. This is the impulse, right? And this acts for a very little time, right? And if We have this force which is variable, so we can calculate this impulse as integration of effort for variable. Okay. So this one is about the impulse. And then we also understood about the other form of this force, that let's say this is F, which is dP by dt, and we can write P as mv. So this is d by dt of m and v. So if we use the product rule, so that would be dm dt v plus this would be v, and this would be m and dv by dt. So what is this dv by dt? RK?
Speed.
Yeah, change in velocity with respect to time. What is that? Rate of change of velocity.
Um,
So this should be remember as big tips. We're doing the kinematics, right? Change of distance is velocity. Change of velocity is acceleration, right? So dv by
yes, sir.
dt is acceleration. Okay. Now, there is a and mass is constant. So this we can take it as, so then your force would be mass, and this dv by dt is acceleration, because this is the second law, right? And then it is represented as F net, that is equal to M. This is the second law of motion. And then we have also second, then we have this conservation of momentum also. And this tells us that momentum inertia, that would be equal to momentum phi. This is the conservation of, right? And then we have this next thing, which is the thrust force. And this is used in rocket propulsion, right? So you have this rocket, right? And this rocket is propelled in the sky. So how it is propelled in the sky?
Sorry,
Yes.
sir. What is propelled inside?
Yeah, so rocket, you have a rocket, right? And then, so the rocket is, let's say, in the station, it is propelled from the surface, right? So how it is
Yes, sir.
propelled above?
By giving force.
Yeah, so what is absolutely right? Because it is moving upward, which means that something is acting against the gravity, and
Yes,
by
sir.
giving the force in the upward direction. So what is giving that? What is providing that force?
Fuel.
Fuel, right? So absolutely right. So
Yes, sir.
fuel is burning. Absolutely right. Good. So fuel is burning, right? And this burning of fuel gives this upthrust force, right?
Yes, sir.
which means that fuel is burning, which means that mass of the fuel is increasing or decreasing.
As the fuel is
Yes.
burning, the fuel will decrease.
So the mass will decrease, right? So now,
Yes, sir.
in that case, this mass will not be constant, right?
No, sir.
So this mass is not a constant and we are moving it with a constant velocity. Then the upthrust force is defined as, so this force is defined as minus v or whatever initial speed you provide and then dm by dt. So this dm by dt is the rate of burning of right. So this whenever you see the rocket question, you use this form. Is this clear? And why this
Yes, sir.
negative sign is there? Why there is this negative sign?
Because it is going against gravity.
No, no. So because dm by dt is decreasing, right? Because the mass is decreasing. That is why, if you calculate, let's say dm would be how much? M final minus m initial. So m final would be how much? This would be small and m initial would be large. So then you will get a negative quantity, right? So that is
Yes, sir.
why there is a negative quantity. Okay, so is that clear?
Yes, sir. Clear.
Yeah, so this, on the basis of these topics, we'll do the questions. So please note these things. These
Okay,
things we
sir.
have already understood. So, yeah. Yeah, whenever you want me to scroll down, please.
Finished, sir.
Whenever you have noted it down, please.
Finished, sir.
And then whenever you have noted it down, and then we'll do
Okay,
the
sir. Okay. Finished, sir.
then let us do some question, and then we'll talk about the degree. So majority, yeah. So first we understood about the impulse, right? So now let us do some question based on. So a ball of mass 0.5 kg is dropped from a height 10 meter, strikes the ground and rebounds. This is the ground ball strikes and then rebounds. Right. So then we have to find out the magnitude of impulse imparted to the ball is the earth. So we have to find out the magnitude of impulse. And we know that impulse is how much? That is P2 minus P1. Right? Change in momentum. That is the impulse.
Yes, sir.
So we have to calculate what is the P2 in here and what is P1. So to do that, P2 would be how much? That would be M V2 and P1 would be M V1, right? So V1 is the velocity with which this ball strikes the ground. And it was dropped from some height. So it had some potential energy and that changed into kinetic energy. So it has some velocity when it is just striking the ground. So we have to find out that. So we will apply kinematics thing. So initially the speed was 0, and as soon as it reaches here, so its speed would be, let's say, v. Okay, height is 10 meter and g is 10. So we know that from third equation of motion, v squared minus u squared, that is 2gh. So v squared u is 0, so that would be 2gh. So v is root 2gh. So this is root 2. G is 10, h is 10. So this is 10. This is v1, right?
Yes, sir.
And it is bouncing right, and it is reaching the same height, which means that it is bouncing with the same velocity. So
Yes,
v1
sir.
v1 is 10 root 2, and what is the direction of v1?
Upwards
v1 it is striking the ground. So
and
what is
downwards.
the
Yes, sir.
so minus g, right?
Yes, sir.
And what is v2 magnitude is say? What is the direction?
Upwards.
So so then we have to calculate what is impulse imparted, right? So that would be m v2 minus of v1. So this is m is 0.15, v2 is 10 root 2 j hat minus of minus 10 root 2 j. This is how much? 0.15, and this is minus minus plus, and that is 10 root 2 j hat plus 10 root 2 j. This would be how much? This would be 0.15 into 20 root 2 j hat. The magnitude would be simply 0.15 into 20 root 2. This is 0.15, 20, and 1.4. So then this is how much? So 15 twos are 3, and 14 threes are 42. This is 4.2 yeah, mass into velocity. So kg meter 0.15 first. This is the answer. Is this clear?
Yes, sir.
So this simple question was asked in 2021. If you have any doubt, please let me know, and otherwise, please click down.
No, sir, no doubt.
Please note it down, and then we'll do the third.
Okay, sir.
Third question will recall your triangles.
Okay, sir.
Yeah, whenever you have noted it down.
Okay, sir. Finished, sir.
So a particle moving with velocity v is acted by three forces shown by the vector triangle PQ1. So we have this kind of a vector, this one, this one, and this one. This is going like this is going like this, and this is going like this is the force. Let's say This is F1. This is F2, and this is F. These are the three forces that are acting. Okay, and now you tell me that you know the triangles law, right? Force a
Yes, sir.
force force is a vector quantity. So let's say if I have this vector and if I have this vector, let's say this is A, B, and C. So this is AB and this is BC. So the resultant of these vector would be what? AC or CA?
AC.
From, from triangle's law, this would be the resultant, right?
Yes, sir.
Good. So you see in here that we have this, let's say I name it as A, B, and C. So CA plus CA plus AB, that would be how much?
CA plus AB, it will be CB.
CB, absolutely right. Good. So CA plus AB would be CB vector. And you see that this vector is signifying that this is BC vector, right?
Yes, sir.
So BC vector. Now if I add the total force F net, so that would be let's say CA plus AB plus of this is BC, right? These are the
Yes,
forces,
sir.
right? But CA plus AB, that is CB. Is that correct or not?
Yes, sir.
So how this CB and BC are related? How BC is related to CB in vector form? Let's say this is some vector A. So how this is related to this vector?
It will be 0.
Negative of this vector, right? This
Yes, sir.
vector, these are negative vectors. If I take it in the opposite direction, so that is negative, right? If let's say this is AP, so this would be minus of AP, right?
Yes, sir.
So BC is minus of CB, correct? So this would be
Yes, sir.
BC and minus of CB. So then this is, so my F net would be 0, which means that I have MA. This is 0, which means that acceleration is 0, which means that velocity is constant. Is that correct?
Yes, sir.
Yeah. So please quickly note down this third part, and if you have any doubt, please quickly note it
Okay,
down.
sir.
And if you have any doubt, please.
No, sir. No doubt. Finished, sir.
Now, let's first question. This we have done. This is from the NCERT, right? This we have done. Let us see if you remember what. Okay, so we have this wall, right? Rigid wall, and we have this right line, and this mass is dropping on this wall. So this has been thrown on this wall. This mass strikes this wall, and then it is reflected, right, with the same velocity. And this has the so then and this angle is 60. This angle is also 60 degrees, right? So then we have to find out that what is impulse imparted by the wall on the ball, right? So impulse imparted by the wall on the ball. And again, that we already know. So impulse is simply change in moment, right?
Yes, sir.
So we have to again figure out what is P2 and P1, and for that we have to calculate V2 and V1. Okay, so let us calculate that. So you see that this is the V vector, right? So this is the initial one, and yeah. So if I break this vector into components, right? So
Yes,
then
sir.
this would be, yeah, this would be what vector? And remember, I'm writing it in this way. So we have to properly write in this way. So this is the vector actually, right? Because we write the tail of the vector from the origin, right? So let's say if I draw the point in here, right? So then this would be what in here. This is 60, so this would be how much?
60 degree.
60 degree. So you tell me that what would be my V1 vector? What would be my V1 vector?
Okay, sir.
In here, vector. You have this vector. You already know the resolution of vector. So what would be this vector?
V cos theta
Yeah, E
cos
cos
60.
and I hat, J hat, or minus I hat, or what?
I had
I hat, and then plus V sine 60, and
minus J.
what would be minus J, right? So this this is uh, this is the V1 vector. Absolutely right. Good. And similarly, we have to write in here. So in here, what do we have? We have so this is the vector, right? This is 60, right? So then what would be this vector V2?
V2
Yeah,
V
this is
sin
yeah,
no, V cos theta minus I
yeah.
cap.
Yes, absolutely right. And
Then plus V sin theta minus J cap.
minus. Good. So this would be V2. So this is minus V cos 60 and minus V sine 60. This is V2, and we have to calculate the impulse. So impulse is V2 minus P1, which is M V2 minus V1. So M V2 is minus V cos 60I minus V sin 60J and minus of V1, which is V cos 60I minus V sin 60J. This is minus so M V cos 60I minus V sin 60J minus V cos 60I plus V sin 60J. So you see that this one is cancelling and we have what? Minus 2mv cos of 60 and I. Minus I hat is representing that this would be the direction, right? And we calculate the magnitude, which would be 2mv cos 60 is 1 by 2. So that would be simply m into 2. This is the impulsive part, right? Is that clear?
Yes, sir. Clear.
Okay, so please note it down and then uh, always remember that this resolution of vector is very important. We have done, we have used it in numerous applications.
Yes,
Whenever,
sir.
whenever we are stuck at some point, just remember this. Whenever you want me to scroll down, whenever you have noted it down, quickly.
Sorry, sir.
Yeah, whenever you have noted it down, when you want to scroll down,
Okay. Yes, sir. Finish.
Yes, done. Okay.
Finished, sir.
Yes, Akib, I've noted it down.
Yes, sir. Finished.
Right. Then we will move on to the next.
Sorry, sir.
Yeah, so take these two questions as you. Okay. Please
Okay, sir.
take this
Okay.
screenshot. Please take this screenshot.
Yes, sir. Taken. Taken, sir.
Because it's the topic which is right. What is equilibrium? If let's say on this particle, if this particle is at equilibrium, which means that all the forces, right, acting on this particle is summed up to be zero. Let's say this is F1, this is F2, this is F3, this is F4. So at equilibrium, what is happening that F net is zero, which means that total forces are cancelling each other out. So whatever forces are acting, they are all cancelling each other out. Right? And we have seen what kinds of forces we have. So we have this gravitational force, so general forces. So we have this gravitational force. Then we have this tension. Then we have this spring force. Then we have this normal reaction. And we have Indian force. Then we will talk about this part later, but we have this frictional force. Right. Frictional force, buoyancy, we'll see it later when we do the next chapter. So that part is also. And that's the buoy. And we have the other force. All these are all on the basis of all these forces will do all the equation. But in equilibrium, we have to remember that at equilibrium, so this is the only thing that we have at equilibrium, your F net is zero, and not equilibrium is F net, and this is equal to F. So you see that whenever the object is at equilibrium, which means that acceleration is zero, right? Which means that either v is constant or v is There are two possibilities, right? But if that is not at equilibrium, then we have this. Right? These
Yes,
are
sir.
the things that we talk about. It. Just write this down and then so gravitational force is gravitational force is this is mg. Then you have this tension that is that depends upon the string, right? And then you have this spring force, so that is kx, right? And that is minus kx. And but its magnitude we can write it as kx. Fourth one is normal reaction, right? Normal reaction, so that is n. And then fifth one, frictional force, that is mu and Sn, right? If that is the static friction, and then you have this sixth one. So F buoyancy, that is M, and in terms of this is written as V rho G. This part we'll cover, but so please note it down. Okay, please quickly note it down, and these type of question we will
Okay,
do
sir.
in. And you start preparing all these first two chapters, right? System and gravitation.
Yes, sir.
So whenever you want me to scroll down, yeah, whenever you have noted it down, please okay.
Yes, sir. Finish. Finished, sir.
This part also.
Yes, sir.
So yeah, we'll stop it here and we'll some question based on the next class and then we'll do friction.
Okay, sir.
Okay, so see you after an hour. After. Allah Hafiz.
Yes,